Alright, this problem says, the International Silver Strings Submarine Band holds a bake sale each year to fund their trip to the National Sasquatch Convention. Wow. But it has been determined that the cost in dollars of baking X cookies is, and then they give us this cost equation here, 0.5x plus 23, and that the demand function for their cookies is p, little p, equals 13 minus 0.05x. How many cookies should they bake in order to maximize their profit? That's the key word here, maximize. I'm going to come back to that in a minute. Well, this little p here, that doesn't stand for profit. This is actually the price. That's, in the demand function, that's what we're talking about is price. So the price depends on the amount that you sell. The amount you can charge depends on how many you are planning on selling. So a few things we need to do here. We need to maximize profit. So first thing I wrote down here was the equation for profit. Profit is notated with a big P, not a little p. It's a big P. So this is big P of x equals R of x minus C of x. That means the revenue that you bring in, take away the cost that it costs to make those cookies. So we know the cost, that was given. I wrote that down here. The cost equation was given, but we don't know the revenue equation. That was not given to us. So we have to come up with that so that we can come up with then a profit equation here. My pencil's not working so good. Okay, so the revenue is going to be based off of the price, because the revenue is the amount of money you bring in. So revenue, R of x, should just be equal to the price that you're charging, which is 13 minus 0.05 x squared. Not x squared, sorry. That's just should be an x there. That's the price up here is just an x. 13 minus 0.05x times however many you sell. Since what we're selling is x, we were just going to times it by x. So we take the price and times it with the amount that we sell, and that's the revenue that we bring in. So I'm going to distribute this through here. That is going to be 13x minus 0.05 x squared. Here's where your x squared came in. Okay, so now that we have our revenue function, we can find out our profit function. So the p of x is going to be equal to the revenue, so that's the 13x minus 0.05x squared. I don't know why this is not working right now, but that's the revenue. Subtract the cost, and the cost is this one that was given to us up here. We have to subtract the whole cost, so I'm going to put it in parentheses so that I remember that I'm not only subtracting the 0.5x, but I'm also subtracting the 23. So I have to remember to subtract both of those. So after I do that, I'm going to come up with this profit function. And as I write them in descending order of power, I'm going to get negative 0.05x squared. Let's see, when I do the minus 0.5x from the 13x, I'm going to get plus 12.5x. And I'm going to have a minus 23. Now hopefully you can notice something about this profit function. It is quadratic. I know it's quadratic because I have the x squared. Also, if I were to graph this, I'm not going to, it doesn't even ask us to, but the leading coefficient is negative. That means if I were to graph it, it would be opening downwards. That's important because this whole problem asked me to maximize the profit. And I said at the beginning, maximize is a keyword. Well, maximize is a keyword. It's the keyword for the maximum, and since this is a parabola, it's quadratic and it's a parabola that opens down, the maximum is this point here where it hits its tip, and that point there is called the vertex. So there is a way to find a vertex of a quadratic equation like this that doesn't take too long. The formula says to do negative b over 2 times A. Well, if I do that, I will find my maximum of this profit function, and that will tell me the amount I would need to sell to get my maximum profit. So I will do negative 12.5 all over, that's negative B, over 2 times A, and A is negative 0.05. As I do that, put in my calculator, I am going to get the answer of 125. 125 cookies will maximize my profit.